Okay, number 8 is asking us a lot of things, actually. Let's start with the first one. It says find the height of the box. So we have a rectangular prism, and I've brought the sketch in for that just to make it a little bit easier. I highly recommend that you put a sketch in as well. We know that the formula for volume is base times height. And so in this case, because it's a rectangular prism, we know we have volume is equal to length times width times height. We've been told that the length and width are 4 by 4. So here we have 4, 4, and we need to find the height. We know the volume is 64 times the square root of 6. So we're solving for h, which means we take 64 times the square root of 6 divided by 16 to give us the height, which leaves us with the height of 4 times the square root of 6, and it looks like it's in feet. Okay, so I'm going to go ahead and mark the sketch. I know this is 4, I know this is 4, and now I know that the height is 4 times the square root of 6. All right, check A off the list. Now we're ready to go to B. It says find the length of the longest stick that can fit inside this box. Now, the longest stick is going to be going from one corner to the opposite corner here. So I'm just going to draw this right here. So it's going from this back corner to this front corner is going to give us the longest stick that will be able to fit inside the box. I hope that all of you can see that without too much trouble. So what we need to know is a couple of things. We already know the height, and we have a right angle sitting here, or actually a right triangle sitting here, and it goes, this is the height, and then this, or one of the legs of the right triangle, this is the other leg of the right triangle, okay? And then that red line that I drew is the diagonal that functions as the hypotenuse of this right triangle with the 2 green legs, if you can see that there. So we can find that leg, we can find that hypotenuse by finding out what this is. Now, do you see that this is functioning as the diagonal of this square right here, okay? So that means I'm just going to call this D for diagonal, okay? And then off to the side here, I can set up the Pythagorean theorem. 4 squared plus 4 squared is equal to D squared, right? Okay, so that gives me the fact that we've got 32 is equal to D squared, which means we can say confidently that D is equal to the square root of 32. Now, it's true that I could go ahead and simplify that, but there's actually no reason for me to do that because it didn't ask for that value anyway. We're going to use this D value here in just a minute to find out what our actual stick length is, okay? So now we know that D is equal to the square root of 32, okay? So now we have to use the Pythagorean theorem again to find the red line. I'm going to call this S for stick, okay? So now we can use the Pythagorean theorem again. We have 4 times the square root of 6 squared plus the square root of 32 squared. See, that's my A squared, my B squared, and then I have that is equal to S squared, representing that diagonal, that red long line that will allow us to figure out how long the stick can be. When we multiply this times itself, we should get 16 times 6. When we multiply this times itself, we should get 32 is equal to S squared. And I believe that will give us, when we add it all together, we should end up with 128. I believe this is 96 plus 32. So now we know that S squared is equal to 128, which means that S is equal to the square root of 128. And 128 is divisible by 16, so we can break that into 16 and 8, because 16 times 8 is equal to 128, which means we can simplify this to be 4 times the square root of 8. We're not done simplifying. That means we can break this into square root of 4 and square root of 2. So this is 4 times the square root of 4 times the square root of 2, which leaves us with 4 times, this is a 2, so that's 8 times the square root of 2, all right? So the longest stick that can fit inside the box, 8 times the square root of 2 feet. And then we're asked, when this stick is placed inside the box, what is the measure of the angle Oh my goodness, they don't stop with the questions, do they? When this stick is placed inside the box, what is the measure of the angle it forms with the vertical face of the box? Remember, vertical is this direction right here. So what we have now is we know the stick is 8 times the square root of 2 long, okay? So what we're looking for is this angle right here, all right? So that means that if we are shooting if we're shooting from this angle here, that looks like we're going to be looking for the, I'm going to say opposite over, we could find it several ways. We could go opposite over adjacent. I guess that's what I'll do. So we're looking for theta. Actually, let me change this color. We've got theta equals the inverse tangent of, and that's the opposite of this is going to be square root of 32. So we have square root of 32 over the adjacent, which is 4 times the square root of 6. And that, if you plug that into your calculator, I'm thinking you should end up with a nice whole degree measure. It'll come out exactly even. But I'm not going to do that for you because you know I've already done a lot for you. And I hope you haven't just watched this, but I hope you've written down all of these steps because that's how you actually get better at these things is by doing them yourself.